All right, let's have a look at 7j. Now, 7j works on a slightly different principle to I, but it works on the principle that we can multiply each of the internal indices by the external indice outside the bracket, the external index outside the brackets. And of course, any coefficients of the x or y, we would simply put to the power of negative 12. But there are no coefficients. We just got an x to the quarter, a y to the third, and so we're going to treat those in the way I just described. We're going to find the new indices by simply multiplying the internal indices by the external indices. So let's have a look at that. And you'll notice, of course, both of these go into 12 rather nicely. They both divide into 12, and you'll see how that plays out in just a moment. So here we go. I'll write this one out. So we've got j. Let's have a look. J. This is 7j. And we've got x to the 1/4, y to the 1/3, all to the power of negative 12. So now what I'm going to do is I'm going to restate this, but this time I'm going to multiply everything by negative 12. And I'm going to take away the bracket. So I've got x to the 1/4 times negative 12. And this time I'm just going to put it negative 12 over 1. And then I'm going to have y, it's all times y to the power of 1/3 times negative 12 over 1. And that's all we're doing. So where do we end up? So nice and simple here. We're going to have, well, 12 times, or 12 divided by 4, because really I could just rewrite that as, and it's x to the negative 12 on 4, y to the negative 12 on 3. And that, of course, simplifies very nicely. We're going to have x, or 4 goes into 12 3 times, so it's going to be negative 3. Y is going to be 3 goes to 12, negative 4 times. And that's as far as I can take that. We make sure these are in alphabetical order, x and y, and there is our solution.